So usually a conical pendulum is, oh, it's a really great fun ride. You probably have ridden on the swings at Six Flags or another amusement park where you get in a swing and it goes around and around. And you go around and around and around in a circle. There's one at the fair that I went to this fall. It's an ugly circle, but there you go, get the idea. This was L, the length, and it makes an angle theta to the vertical, and that's usually the way they're drawn. Maybe it's on a big, gigantic, rotating cylinder, and all the little strings are attached to it, and it starts spinning, and everybody swings out. So the free body diagram would have a tension force up and to the right for my picture, and a weight force straight down. Again, you can draw it as F sub G. If you forget that F sub G is mg, then maybe you want to just start drawing it as mg. Okay? So in this case, the center of the circle is over here. That would be the center right there drawn. The center over here, and we don't want to move our axis because we want the x-axis to be the same direction as the acceleration. So let's sum the forces in the x direction. The x forces are radial. So summing the forces in the x direction, same thing, MAC. And I sum the forces in the y direction. They are 0. So the x force would be the tension component that's in the x direction. The angle is to the vertical, so that's a little bit tricky, so it's going to be the sine of the angle. And that will be equal to MAC. And the y component would be FT cos theta. It's like a weird cross, doesn't it? Let's get rid of that guy. Anyway, and then minus mg equals 0. So, oh my goodness, doesn't this look like the banked curve? Sine, I don't know why I'm rewriting that, because that's just a waste of time. But hey, isn't FT cos theta equal to mg? So the banked curve with no friction in the conical pendulum are the same. The difference is the normal force versus the tension force. That's all. And then from there you can substitute and solve. Now what the trick I was mentioning earlier is, let's say you were trying to find an expression for the velocity. So find v. So I could do a little shortcut and say ft sine theta, because sine over cosine is tangent. Divide this over. Alright, so from here, it's just a shortcut to make the ratio. Look at this. Boom, 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 boom. Now, sine over cosine is, this guy right here goes to, what, tan theta? What's AC? V squared over R and then over G. So this will be like an RG right there. Yeah. So V would be equal to root RG tan theta. And that's just one thing you could solve for. It comes up often, so that's worth practicing.